Hi, today we will be doing with additive interval property. It comes under integration. So let's start with additive interval property. The theorem states that if f is integrable, if f is integrable on three closed intervals a, b and c, on the three closed intervals A, B and C, then integral A to B f of x dx is equal to integral A to C f of x dx plus integral C to B f of x dx. So I'll just repeat the theorem again. Today our topic is about additive interval property. If f is integrable on the three closed intervals a, b and c, then integral a to b f of x dx will be equal to integral a to c f of x dx plus integral c to b f of x dx. I'll just explanation. Suppose we have an integral like this, like say, suppose I'm considering the number line. Suppose we have an integral like say a is from -3 and b is 3. So our interval is lying from -3 to 3. So this is -3 to 3. So as per this additive interval property, I can split this into two separate limits. That is, say from -3 to -3, -3 to 0, and then again from 0 to 3. So -3 to 0 and then from 0 to 3, like this here. I'll consider from -3 till 0. So it will be written as -3 to 0 f of x dx plus integral 0 to 3 f of x dx. Our question was from -3 to 3 dx. So let's do with an example now. An example to make this theorem more clear. Find integral -1 to 1 mod x dx. Find integral -1 to 1 mod x dx. Mod x, modulus of x. So we'll check whether how the graph of mod x will be there. Find integral from mod x. So this is the graph of mod x. Those are having doubt, I'll just show here. Mod x means when x is 0, mod x is also 0. When x is 1, modulus of a positive number will be always positive. When x is -1, still modulus of a negative number also will be positive. So in that case, when I mark this is 0, 0, this will be 1, 1, this will be -1, 1, and then 2, 2, -2, 2. So it will go on like this. So this is the graph of mod x. It's a V-shaped graph. Now for this V-shaped graph, now our question is from -1 to 1 mod x dx. So I'm going to, as per the above theorem, I'm going to split this into, so this is -1, 0 and 1. I will split from -1 to 0 and then from 0 to 1. From -1 to 0, the graph is on the left hand side. So modulus value will be negative, and from 0 to 1 it is on the right hand side. So graph will be having a positive value. So let's check that again. So for me the question will be negative 1 to 1 mod x dx is equal to negative 1 to 0, which is minus x dx, plus integral 0 to 1 plus x dx. Now we will use the integration rule. Integral of x raised to n dx is x raised to n plus 1 upon n plus 1 plus c. As it is a definite integral, there is no need of adding that c there. So here, now we will do this one. So integral x raised to n. So the first part will be negative x squared by 2 from the limit negative 1 to 0. And second part will be x squared by 2 from integral 0 to 1. Now we have to give the upper limit and the lower limit. So upper limit, that is 0 squared by 2 minus this again minus 1 squared by 2 plus 1 squared by 2 minus 0 squared by 2. And when you simplify this, you will get this here as 1 by 2, and here again 1 by 2, 1 by 2, 1 by 1 by 2, that is 2 by 2, that is equal to 1. So the final answer here it is 1 for integral minus 1 to 1 mod x dx is equal to 1. So I hope today's video, it was about additive interval property. It's clear. Thank you so much.